Ninth one. Laplace transform of e power minus at sine omega t. Now, f of t is given by e power minus at sine omega t. We can write in exponential form, that is e power j omega t minus e power minus j omega t divided by 2j. Now, let us try to simplify this. This 1 by 2j of e to the power of minus a minus j omega t minus e to the power of minus a plus j omega of t. The Laplace transform of the above function is given by 1 by 2j of, this is e to the power of at. We have already seen that e to the power of at function will be getting 1 by s plus a minus j omega minus 1 by s plus a plus j omega. Now let us solve this. 1 by 2j of s plus a plus j omega minus s minus a plus j omega divided by s plus a whole square plus omega square. F of s equals to omega divided by s plus a whole square plus omega square. Next, Laplace transform of e power minus at cos omega t. For this, integral 0 to infinity cos omega t e power minus at of e power minus st dt, that equals to 0 to infinity cos omega t e power minus a plus s of t dt. Then, when you solve this, 1 s plus a cos omega t e power minus s plus a of t plus e power minus s plus a of t omega sine omega t divided by s plus a whole square plus omega square between the limits 0 and infinity equals to. Now let us substitute the infinity. If you substitute the infinity here, this term will be 0 plus this term is also 0, and next minus of 0 term, then minus s plus a cos 0 will be 1, and this term will be 1 divided by s plus a whole square plus omega square plus 0 of this sin 0 is 0. Now you can write from this that s plus a divided by s plus a whole square plus omega square. So for this, Laplace transform function is s plus a divided by s plus a whole square plus omega square. Next one, Laplace transform of delta t. From the definition, f of s equals to integral 0 to infinity delta t e power minus st dt. Now we have already seen this equals to 1 for unit impulse function. Laplace transform of sin h theta t, for which f of t equals to sin h theta t, that equals to e to the power of theta t minus e to the power of minus theta t by 2. Now f of s equals to integral 0 to infinity e to the power of theta t minus e to the power of minus theta t divided by 2 e power minus st dt. This you can write 1 by 2 integral 0 to infinity e power theta minus s of t minus theta plus s t. Now let us solve this. F of s equals to 1 by 2 of 1 by s minus theta minus 1 by s plus theta, that equals to 1 by 2 s plus theta minus s plus theta divided by a square minus b square, that equals to 2 theta divided by 2. So theta divided by s square minus theta square is the Laplace transform function of sin h theta. Laplace transform function of cos h theta t. Now f of t equals to cos h theta t, that equals to e power theta t plus e power minus theta t divided by 2. Now let us solve this. Then f of s equals to integral 0 to infinity e power theta t plus e power minus theta t divided by 2 of e power minus st dt, that equals to 1 by 2 0 to infinity e power minus s minus theta t plus e power minus s plus theta t dt. Now when you solve this, We'll be getting 1 by 2, 1 by s minus theta plus 1 by s plus theta. Now solve this. 1 by 2 s plus theta plus s minus theta divided by s square plus theta square. 2 times 2, 2s. So this will be s divided by s square plus theta square. So this is for the cos theta h. These are the Laplace transforms of the common forcing functions. Let us remind them. So first we found the Laplace transform for the unit step function, for which Laplace transform is 1 by s. The second one for exponential function e power minus at, for which we got 1 by s plus a. The third one is the sinusoidal function, that is sin omega t, for which we got omega by s square plus omega square. And fourth one for sinusoidal function, that is cos omega t, for which we got s divided by s square plus omega square. The ramp function, that is for t, which we got 1 by s square. The sixth one for the parabolic function, that is f of t equals to t square, we got 2 divided by s cube. And we have a general formula that we found for t power n, from which we got the formula that n factorial divided by s to the power of n plus 1. Then eighth one for unit impulse function, we got the s domain equals to unity. Now the ninth one for e power minus at t to the power of n factorial divided by s plus a to the power of n plus 1. Now the 10th one for e power minus at sin omega t, omega divided by s plus a whole square plus omega square. 11th one for the function e power minus at cos omega t, the Laplace transform is s plus a divided by s plus a whole square plus omega square. And 12th one sin h theta t, for which we got theta divided by s square minus theta square. And finally cos h theta t, we got s divided by s square minus theta square. Laplace transforms of some useful functions.